All right, we're covering 5.3 Part 1 today, and that's going to be solving quadratic equations by graphing or factoring. Some terminology. The zeros of a function is a value of x that makes the output f of x equals 0. So it's what values of x will make y, what we have called y in the past, 0. The zeros of the function are the x-intercepts, and that's kind of by definition. When the coordinate when y is equal to 0 is your x-intercept, and that's essentially what the zero of a function is as well. So unlike linear functions, they have 1, 0. We solve for x, and you're going to get one solution. Or if we set y to 0, you're going to get one x-intercept. Quadratic equations can have 2 zeros, and you probably could figure that out because of the shape of the parabola. And notice here's our axis of symmetry. The zeros are symmetric about the axis of symmetry, and we're going to take advantage of that to help us graph functions to find solutions. So let's look at this example. Find the zeros by using a graph and a table. So we've learned a few things about the graphs. We learned that if A is positive, it opens up. If it's negative, it opens down. So we know this opens up. We know the y-intercept is our C. And we can find the vertex. X equals negative b over 2a. So that's the x-coordinate of our vertex. The y-coordinate's going to be f of negative b over 2a. So if we plug this value into our equation, we plug this value into the equation and get the output value, that's going to give us the y, and that doesn't really look like a y, but that's going to give us the y-coordinate of our vertex. So with our knowing what our y-intercept is, knowing that it opens up, knowing that what our vertex is, and in this case it's going to be 3, negative 1, now we can start making our table. Basically we want to start making our table from our vertex, which is our axis of symmetry, because we know that symmetrically on either side of that is going to be our zeros. We don't know necessarily how far out, but we're eventually going to get to the points that are zeros. And in this case, it's very easy. Here's our axis of symmetry or vertex. If we go out 1 in either direction, and that's what you want to do, start from your vertex, go out 1 in both directions, calculate the value. So we're plugging 2, here we're plugging 2 into this equation, here we plug 4 into this equation to get our values, and we can see that the next value over is going to be our zeros. And to graph it, you want to go out 1 more, even though we've actually already found out what the zeros are. So you're going to plot the points. And there's your graph, and there's your x-intercepts, which are your zeros. Okay, would like you to try this one. So find your axis of symmetry and then move out in both directions to see if you can find your zeros and graph that function. All right, so to add another piece of terminology that's a bit confusing with zeros because it kind of means the same thing in our context, the solution to a quadratic equation of the form ax squared plus bx plus c equals 0 are the roots. So notice that here is our y value and it's 0. So that means also that the solution is going to be the values of x that make y 0. So those you can also call those the zeros. But the roots has a more general definition. The roots of an equation are the values of the variable that make an equation true. It just happens in this case that to make the equation true, we want y to be 0. So you're going to see questions asking you for the zeros. You're going to see questions asking you for the roots. And essentially we're asking you, it's the same question with just different terminology. All right, zero product property. So we're going to move on to solving by factoring. And we use zero product property. Because remember, when we factor, we usually get 2 terms of some sort. And if we want to find the roots, is going to be equal 0. If either one of these expressions here is equal to 0, when we multiply it with the other one, it's going to be 0, because 0 times anything is going to be 0. It doesn't matter what you're multiplying it by. So that's what the zero product property says. If the product of two quantities equals 0, at least one of the quantities equals 0. So here we have the second term being 0. Here we have the first term being 0. It doesn't matter which term it is. If it's 0, the product of those, or when you multiply them together, you get 0. We use that fact to help us solve when we factor. So quadratic expressions can have 1, 2, or 3 terms. So here's a 1 term, here's 2 terms, and here's 3 terms. Normally we're going to be working with 2 or 3 terms. Quadratic expressions with 2 terms are called binomials. Quadratic expressions with 3 terms are called trinomials. And we did some factoring. These are special factors. They're just special. Well, actually they're not special. You could factor them or FOIL them just like anything else. But if you could, this is just basically a shortcut. If you can remember, a squared plus b squared is always equal to a plus b, a minus b. We'll use this the rest of the year. So remembering this or getting used to this fact is going to help you. And then this a squared minus 2ab plus b squared is equal to a minus b squared, and a squared plus 2ab plus b squared is equal to a plus b squared. These I don't remember so much. I can figure them out. This one I do remember. I just remember a squared minus b squared is a plus b and a minus b. All right. So if that helps you, that's great. Else you would just be factoring as normally. Okay, find the zeros of the function by factoring. So here's our function f of x equal x squared minus 4x minus 12. So we are going to put it in standard form, set it equal to 0. Then we're going to factor. Remember, we're looking for a and b so that they multiply to be negative 12. And they add to be negative 4. What are factors? Well, we know 3 and 4, but I know right off the bat that it's going to be a is a negative 6, b is going to be 2, a plus b is negative 4, a times b is negative 12. So it's going to factor into this x minus 6 and x plus 2. So to find the solutions, remember, if either one of these is equal to 0, then the whole thing is 0. So we're going to have 2 solutions. And remember, what are those solutions? Those solutions that we're going to get from this are going to be these points where y is equal to 0, because that's what we're solving for. So set x plus 2 equal to 0 or x minus 6 equal to 0. Either of these terms equaling 0 is going to give us 0 up here. Solve for x, so here we subtract 2, here we add 6. So our 2 solutions are x equals negative 2 or x equals 6. And remember, what does that mean? That means that 2, 3, 4, 5, 6. And just roughly, that means these are where our x-intercepts are. This opens up, so it's going to be something, and I know that's not a very good sketch, but it means that this is where that graph intersects the x-axis. And remember, especially on a test, check your answers by plugging them in. Plug in negative 2 right here, and make sure when you calculate this value you get 0, and the same with 6. It's always a good idea to check your answer. All right, next equation, 3x squared plus 18x. This is a binomial. So we can't really factor this like we did the first one, but one thing I'm going to try and pound into your head is when you're factoring, the first thing you should always check for is greatest common factor. Even before we do, I should have mentioned it, even before on this first one, I should have seen, can I factor anything out of each term? The answer is no, but I should have checked. Here I can't. I can factor out a 3, and they both have 1x, so I can factor a 3x out. So when I do a greatest common factor, it's like dividing each term by that expression. So I pull out my 3x, which is my greatest common factor, and when I divide 3x squared by 3x, I cancel the x out, the 3 out, and then I cancel one of my x's, so I'm left with just x here, which is this one. When I divide 18x by 3x, this cancels out. 18 divided by 3 is 6. So now I'm left with this. And here, this is simplified enough. I'm going to set each of my factors, which are 3x and x plus 6, to 0, just like I did up above. Here I'm going to divide both sides by 3. Here I'll subtract 6. X divided by 3, 3x divided by 3 is x. 0 divided by 3 is 0. And here I have negative 6. So I see sometimes students get confused about this. How do I solve for x? Just pretend you don't know what's over here. If you wanted to solve for x on this, you would divide the 3 out, and you do the same here. And 0 divided by anything is 0. So these are your two solutions, x equals 0 or x equals negative 6. All right, here's one for you to try. Okay, we're going to try a few more. Find the roots of the equation by factoring. So notice this is not in standard form. We want to put it in standard form, ax squared plus bx plus c equals 0. So to do that, we're going to subtract 25 from both sides. Now we're in standard form. And this is basically the product or the difference of perfect squares. Remember, x squared minus a squared minus b squared equals a plus b and a minus b, where these are a is equal to the square root of a squared and b is equal to the square root of b squared. This is the difference of perfect squares. If I square root this, the square root of 4 is 2. Square root of x squared is x. So this is going to be, so a is essentially 2x. The square root of 25 is 5. So this turns into 2x plus 5 and 2x minus 5. It's the special product, the difference of two perfect squares. Once I get to this point, I set each of them to 0. I've factored them. Now I set each factor to 0. First thing I'm going to do is subtract 5 here, add 5 here. So let me show you that part here. Plus 5 equals 0. 2x minus 5 equals 0. Subtract 5, add 5. You end up with 2x equals negative 5. 2x equals 5. Divide by 2. So your solutions are x equals negative 5 halves, x equals positive 5 halves. Okay, another example. X squared equal 48x minus 32. Again, want to put it in standard form. I could move this over there, but you want to have the a be positive if possible. So in this case, instead of moving 18x squared to the other side, I'm going to move these two over to this side. So I'm going to subtract 48x and add 32. Now again, greatest common factor. Do I have something that I can factor out of each of these? And the answer is yes. I can factor each of these by 2. So when I do that, I end up with this. And again, this is another special product. Notice this is a perfect square and this is a perfect square. So you're going to square root. It's square root of 9x squared. Square root of 9 is 3. The square root of x squared is x. And the square root of 16 is equal to 4. So this is going to be, and notice how this is a negative here. So it's going to be 3x minus 4 times 3x minus 4. This is going to be one of those special factors. All the special factors, one thing they have in common is the first and last term will be perfect squares. So if you see that, that might key you that it's going to be one of those special factors. So 3x minus 4 squared, notice you're going to have the same factor twice. You don't need to do this twice because you're going to get the same answer. And the answer is 4/3. So you don't need the or 4/3 because you only need it once. And what this is going to look like, 4/3, is it's going to be something, and we have a positive, so it's going to be something where the vertex is on the x-axis. That's why you only have one x-intercept. Graphing them can help you kind of understand these a little bit better. All right, so this is one for you to try. And that wraps up this lesson. Here's your homework, and there will be a new web activity up. Bring questions to class.